In this video, I'd like to help you walk through examples in section 4.5 in the old textbook. In our new textbook, it's section 5.5 or homework number 5. In this section of examples, what we're going to do is find some functions that cannot be easily simplified. You could simplify this 2 plus x to the 4th to the 5th. You could expand it, but it would be quite a cumbersome function to work with there. Because after we expanded this, so that's 2 plus x to the 4th times itself 5 times, we'd have to then distribute the x cubed. So we needed to find another method of solving these types of problems, substitution. For this first example, for several of the examples, like for example the number 3 and number 5 in the textbook problems, or on my math lab number 4 and 5, the substitution is given where you're told let u equal 2 plus x to the 4th. So here's the method you use to solve these. And if you want to write a list of steps off to the side for yourself, you could use that list of steps when you go back to do the homework on your own. But the first, and then to find the derivative of this u substitution. So if u is equal to 2 plus x to the 4th, then the derivative of u is going to be 4x cubed dx. Make sure you're keeping straight the difference between doing a derivative and integrating. The next step after we find the derivative of u is to put the substitution in. So we've got 2 plus x to the 4th is what we're substituting u. So we take this 2 plus x to the 4th and replace it with a u. To build the du, we need to build a 4x cubed dx. And we don't have a 4, we only have the x cubed dx. But it's very easily built by multiplying by 4 and then dividing by 4 on the outside. So you see with dx, so that we can build our du, which is dx, we can build our du by multiplying by 4. For the integral of u to the 5th du. When I integrate u to the 5th, I get the 6 over 6, multiplying that by 1/4. We get 1 over 24 u to the 6 plus our constant. And the last step is simply to go back and replace the u with our substitution 2 plus x to the 4th. So we get 2 plus x to the 4th to the 6th power over 24. There is no need to expand this. We're going to leave it in this exponent form. We can also use substitution with some trigonometric functions. So in example 5, we're given that we should use equals cosine of theta. Now if u is equal to cosine of theta, then our first step is to find the derivative of u. The derivative of cosine is the opposite of sine delta times d theta. And then we need to build this du from. If we built the du, what we'd have is we've started with a cosine cubed theta times sine theta. And if u is going to be cosine, this cosine cubed theta or cosine theta cubed is u cubed. And then we need the negative sine theta, which we can build from our sine theta. Notice we had was a sine theta. We can build the opposite of sine theta by multiplying by a negative and then multiply by a negative outside the integral. So now we have the du. That is all the substitution part. Again, first we took our substitution and found the du, and then we built the du from what we had, and then we rewrote our integral using u and du. The next step is to integrate. That's the easy part from here. And we get the opposite of u to the 4th over 4 plus our constant of integration, c. And the last step is to substitute back in. So going back here, we find theta for u. So we're going to replace this u with sine theta. So our end result ends up being the opposite of cosine theta to the fourth over 4 plus c. Or we could call it negative 1/4 cosine theta to the fourth plus c, which would look like this. Let's look at another example where you're not given the u. You're not given a hint for what to use for substitution. The good news about our in fact always work out pretty easily, but you do sometimes have to a few attempts before you get something that works. Let me give you a few hints on what will often work for you. When you look at this example and you can pick out what's the complicated part of the problem, you see that the complicated part of the problem is the radical. And so this radicand, the 1 minus x squared, is going to be the best piece to use a u for. And so we guess that u is going to be 1 minus x squared. And then we check to see if we can build a du. du is going to be negative 2x dx. And sure enough, that is going to be easily built from our x, because we'll just need by a negative 2 and then undo that by multiplying by a negative 1/2. So by multiplying by negative 2 and then multiplying by a negative 1/2, we can build this du. So that's how we know substitution u equals 1 minus x squared is going to work. So then I rewrite the integral as negative 1/2 times the integral of the square root of u du, and then it's just integrating from there. When I integrate the square root of u, I'm going to think of it as u to the 1/2. So we get u to the 1/2 plus 2/2 is 3/2, divided by 3/2, which is the same as multiplying by 2/3, plus our constant of integration. You could, in some cases, leave it like this other than simplifying the negative 1. You also need to put in the back substitution in the u. So let u equal this 1 minus x squared. So we'll put in 1 minus x squared for u. And you might see it left with rational exponents, or you could put it in a radical form also. Let's look at another example, an example using some trigonometry. Sometimes you have to manipulate a little bit more. Here's an example. If u is tangent x, then the derivative of tangent is secant squared x. So we can build our secant squared x from the pieces that we started off with. So if we pulled out a u, or actually u is going to be squared. So if we pulled out a u, if we replace tangent x with u, we'd have u squared. And then here's our du. Here's what makes the definite integral with, notice that our indices of integration are written for x. X is 0 up to x is pi over 4. But we've got u. Change our index, x equals 0, to find what u would be. So here's how we do that. U is equal to tangent of x. And if x is 0, then we'd have u equal to the tangent of 0, which is just 0 because sine of 0 is 0. And then if u is tangent of x and x is pi over 4, then we'd find that when x is pi over 4, u is equal to 1 over the square root of 3. This is just the trig review that gives us that. So notice that if we're doing a definite integral, when we have indices, we have to be mindful of swapping these x's out, u values, in addition to the substitution that we do. So this blue cloud area is just a trig review. Next, we're going to integrate. And when we integrate u squared, we get u cubed over 3. And this is going from u equals 0 to u equals 1 over 3. Substitute in the u equals 1 over square root of 3. Substitute in, and we'd simplify this to 1 over 9 square root of 3. There's the denominator. You can feel free to leave it with a radical in the denominator, but if you do rationalize it, we'd multiply by the square root of 3 over the square root of 3. So we'd end up with square root of 3 over 27. I do have one for you because this example is a little bit trickier. We get one more added piece to this one. And here, when we do the substitution, again thinking of what's the most complicated piece, that's this radical. So we're going to use the radicand, 5 plus x, for the substitution. So the derivative of u will just be dx. But notice when we replace this dx with du, we've got an extra x left over. So what we have is u going from 4 to 9. And when we do this, we've got a du and a u, but we still have this extra, x for the dx is equal to du, but we've still got this extra x left over. So the problem becomes, okay, what do I do with this x? It's easily solved when we go back to the substitution, because if u plus x, then solving for x, we get that x equals u minus 5. So when we rewrite this integral, we're going to say that u goes from 4 to 9. X was replaced with u minus 5. And then we've got the square root of 5 plus x is the square root of u times the derivative, or over the du. Now it's just simplifying this, u over the square root of u, and integrating. When you integrate, you'd get the 3/2 over 3/2, which is the same thing as multiply 2/3, minus u to the negative 1/2 plus 1/2 is u to the 1/2 over 1/2, so that's going to be the same as multiplying by 2. So 5 times 2 gives us 10. And when you substitute in a 4, substitute in a 9, and subtract, you should end up with an 8 over 3. But the video won't, I don't have time in the video because the video won't load if it's too long. So I won't have time to work out this arithmetic here. But you can use a calculator to do that arithmetic.